Well, hey everybody, Mr. Reeves back with you. And in this video, we're going to be doing some practice problems from lesson 7.2 on writing two-step inequalities and lesson 7.3 on solving two-step inequalities. All right, so I'm going to start by skipping over to page 216. I meant to go to page 216. Well, maybe I'll just do it this way. We're going to start by looking at some different phrases because when you are writing or solving problems involving two-step inequalities, you got to learn to look for words and the meaning of them in terms of greater than, less than, greater than or equal to, or less than or equal to. All right, so here we go. So M is at least 25. So if you have at least 25, what does that mean? You have 25 or more, right? So that would be greater than or equal to. All right, what about no greater than? Well, if you're not, sometimes I'll put like a little T on there. If you're not greater than, what does that mean? That means you are less than or equal to, right? 9 is not greater than 9, and anything smaller than 9 is not greater than 9. So no greater than is less than or equal to. All right, is less than, well, that was not so bad. They give us the exact words, less than. Is no more than, again, if you put a T, is not more than. What numbers are not more than -5? Well, it can equal -5, right? Or it can be less. So if it is no more than, that means it's not more than, which means it has to be less than or equal to. Is at most. Well, if it's at most 56, it could equal 56, but it would have to also be less than. So is at most, hey, I hope you're in class, there's the bell. Less than or equal to 56 is at most. And finally, is no less than, again, no less than, put a T on there if it helps you out, not less than 0. Well, what kind of numbers are not less than 0? Well, if it equals 0, we're good, or if it's greater than. So greater than or equal to 0. Okay, so these are phrases that you want to familiarize yourself with so you know what inequality symbol to use with those phrases when you are writing and solving two-step inequalities. All right, let's go ahead now and just solve some two-step inequalities. Actually, before we solve them, let's do some testing, shall we? All right, so I'm going to do these ones right here because you are asked to do this on your assignment. They're going to give you values and ask you, does it make the inequality true? Now, remember with equations, we had to make the left side equal the right side. Now we just have to make it true, which means for this one, the left side has to be greater than the right side. So let's try -12. 2 times -12 plus 18, is that greater than -4? All right, well, 2 times -12 is -24. -24 plus 18, well, I think that's 6, right? Or -6, rather. Is -6 greater than -4? No, actually, -6 is smaller than -4. So -12 does not work. All right, what about if we try -11? 2 times -11 plus 18. Well, that's -22 plus 18. Well, guess what that is? That is -4. All right, is -4, and you got to be careful on this one. Is -4 greater than -4? Actually, -4 is not greater than -4. It's equal, so that one doesn't work. I sure hope -10 works. Pretty sure it is going to work, right? 2 times -10 plus 18. Is that greater than -4? Well, what do we get? We get -20 plus 18. Is that greater than -4? Well, -2, guess what? It is greater than -4. So this is the one that is greater. All right. Just so you know, an alternate way to do it would be you could just solve it, right? For example, -6y plus 3 is greater than or equal to 0. If I just want to solve it instead of plugging it in, if I solve it by subtracting 3 from both sides, remember in a two-step equation, we're going to do the opposite operations in the opposite order or the inverse operations. I get -6y is greater than or equal to -3, and then I'm going to divide by -6. And remember, bells and whistles going off in your head because you divided by a negative, so you're going to reverse or flip the inequality sign. you get y is less than or equal to 1/2. All right, so if y has to be less than or equal to 1/2 to be a solution, well, 1 is not less than or equal to 1/2. That one doesn't work. All right, 1/2 is less than or equal to 1/2, and 0 is less than or equal to 1/2. So actually, it's a little bit nicer just to solve it and then see which of the choices that they give you actually work. But that is completely up to you how you decide you want to do it. Okay, so let's do a few more of these problems. Remember, solving a two-step inequality is just like solving a two-step equation, inverse operations in the opposite order. However, if we multiply or divide by a negative, we are going to have to reverse that inequality sign. All right, so I've got 2 times s plus 5, so going in the opposite order. I'm going to subtract 5 first, right? I'm going to write it over here. That's going to give me 2s is greater than or equal to 44. And the inverse of multiplying by 2 is dividing by 2. And that's going to give me s is greater than or equal to 22. All right. And then remember, when we go to make a graph, we're going to find that boundary number 22. It's greater than or equal to, so that means it's going to be a closed circle. All right. And where are they greater? Greater goes to the right. So I'm going to go ahead and draw my line here. Try to actually stay on the line. All right, this is stupid, Mr. Reeves. Just draw your stinking little line there. It doesn't matter if it's perfect. There we go. All right, so there's my graph of s is greater than or equal to 22. All right, what about this one? This one I'm going to go ahead and subtract 9. All right, and that's going to give me negative 3t. And by the way, I subtracted 9 because that is the opposite of adding 9. Negative 3t is greater than or equal to negative 30. And now I'm going to divide both sides by negative 3 because that's the opposite of multiplying by negative 3. But again, bells and whistles going off in my head because I divided by a negative. So I'm going to reverse that inequality sign and make it less than or equal to. And a negative divided by a negative is a positive, and 30 divided by 3 is 10. So less than or equal to 10. All right, so I'm going to jump over here. I'm going to put a closed circle because it has an equal sign on it. All right, and you know what? This time I think I'm going to use the arrow because there's no way I'm going straight for that long. Here we go. Let me make it a little bit wider on here. It's going to go that direction. There we go. Beautiful. I should have just done that the first time, right? I should have done that one on here. All right. You can't even tell I did it. Okay. All right. How about this one right here? I'm going to skip down to number 12. A divided by negative 8 plus 15 is greater than 23. All right. First thing I'm going to do is take away that 15 that was added, right? And that's going to give me, I'm going to write it over here, A divided by negative 8 is a greater than 23 minus 15. That's going to give me 8. All right. And then I'm going to multiply because the inverse or opposite of dividing by negative 8 is multiplying by negative 8. And again, bells and whistles going off in my head because I multiplied by a negative. So I'm going to reverse that inequality sign and get A is less than negative 64. A is less than negative 64. So when I go to negative 64, I'm going to put an open circle. All right, and then I'm going to go to the left because those are where the values are less than negative 64. All right, so there are some more practice problems on solving inequalities. By the way, if you get one with a decimal or a fraction, you are welcome to use a calculator. The process is not any different. Okay. All right, let's do this problem here, number 19. Grace earns $7 for each car she washes. She always saves $25 of her weekly earnings. This week she wants to have at least $65 in spending money. How many cars must she wash? Write and solve an inequality to represent this situation. All right, so she's going to save $25. She earns $7. All right, so here we go. So 7 times each car she washes. Let's use C for the number of cars she washes. So that is the amount of money she is making, right? That is the amount of money she is making washing cars, all right? But she's going to save $25. So I'm going to take that away. And the reason I'm taking that away is because she wants to have $65 in spending money, okay? So if she was going to spend all her money, then we would just have that 7C, but we're going to take away what she's going to save, which means when I go to solve it now, she doesn't have to earn $65. She has to earn what? When I add those together, 65 plus 25, that's going to give me what, 90? All right. So is that correct, right? 5 plus 5 is 10, so 90, and then I divide by 7. All right, so let's go ahead and get out our calculator, and let's do 90 divided by 7. And what do we get? We get C is greater than or equal to 12.9. All right. So assuming she's not going to wash 12.9 of a car, 12.9 cars, right? What are we going to say? We're going to say 13 cars or more. All right? Or greater than or equal to 13 cars. Does that make sense? Because 12.9 is what it would come out exactly. And again, if we wanted to check our answer, let's say that she washed 13 cars. 7 times 13 is equal to 91, and then if I take away that $25 that she saved, that gives her $66 that she can spend. All right, hope you liked that one. Okay, now I want to actually go back in time, see if I can get it right this time to page 215, because they have some more word problems back in the previous section. All right, it's another car wash problem. 3 friends earned more than $200 washing cars. They paid their parents $28 for supplies and divided the rest of the money equally. Write an inequality to find possible amounts each friend earned. Okay, so let's see. We've got 3 friends earning more than $200. All right, so they earn more than $200. All right, we want to write an inequality to find the possible amounts each friend earned. All right, so if we make the total here, right, they paid their parents $28. We're going to have to take away that $28. All right, now the question is, when it says 3 friends earn more than $200, does that mean $200 each or $200 total, right? So if I take the amount of money that they earned, right, and I divide it by 3, well, that would take the amount and break it up into each person, okay? If I multiply it by 3, well, then that is going to be what I want, right? Because I want to say this is for each person, okay? Does that make sense? You might think we want to divide it by 3, but actually we want to know what each person earned, multiply it by 3, take away 28, and it's greater than or equal to 200. Okay, so then to solve this, we would add 28 and we would divide by 3. All right, let's look at another problem right here. How about number 12? Lincoln Middle School plans to collect more than 2,000 cans of food in a food drive. So far, 668 cans have been collected. Write an inequality to find the number of cans the school can collect on each of the 7 final days. Okay, so they have 7 days, right? And those 7 days, they need a certain amount, but they already have how much? 668. So this is what they need, right? This is what they have. And what do we want? We want more than. So we want to do greater than $2,000. All right, what about this one? Joanna joins a CD club. She pays $7 per month plus $10 for each CD. So there's that one time $7 plus $10 for each CD, and she wants to spend no more than $100. Well, no more than $100 would be less than or equal to $100. Again, to solve this, we would subtract 7 and we would divide by 10. All right, so I forgot the page number. Let me go back to those problems we were working on. All right, and I wanted to do, let's see here, these last two problems, and then we're going to be done. Okay, all right, right here. Is there any value of x for which x is less than x minus 1? Well, think about it. Is it possible to have a number smaller than when you take one away from it? Well, let's just solve this for x, right? We want to know the value of x that makes this true. When is this true? Well, it's an equation, or rather an inequality, with variables on both sides. If I subtract x from both sides, what happens? I get 0 is less than -1, right? Do you remember those equations that had infinitely many solutions or no solutions? All right, we looked at it and said, after we eliminate the variables, is it true or is it false? Is 0 ever less than -1? Well, that's false. 0 is always bigger, so it is not possible. So this is an example of an inequality that has no solution. Okay, so is there any value? No, there is no value. There is never a time that a number is smaller than a number that is one smaller than it, right? That's what this says. Give me a number that is smaller than a number that is one smaller. It doesn't work that way. And finally, all right, compound inequalities. This is something you will be doing next year in IM1. All right, for those of you that make it. Compound inequalities are when you put two inequalities together and you join them by and or. And means both have to be true, or means one or the other has to be true, like greater than or equal to. It can't be both at the same time. So let's take a look at this one. X is greater than 2. Well, if I were to graph x is greater than 2, I'm going to put it up here. That would be an open circle on top. And I'm going to go ahead and go back to my arrow. And that would go that way. That would be x is greater than 2. All right, let me change colors here. If I was going to do x is less than 7, that would be an open circle. And then I would have an arrow that went that way, right? So the red one on top is this one right here. The red one is x is greater than 2. The blue one is x is less than 7. And means both have to be true. So if I were to say, where are both of those true? All right, let me make this dotted here if I could, right? And let me make it black, that way we can see here. Okay, I'm gonna go down there, right? And I'm gonna go there. So everywhere in between those two is what I want, okay? So what do I want? I want an open circle on 2 because 2 does not work. Let me get black here. I was trying to get black. I want an open circle on 2, and I want an open circle on 7, and then I want that line in between. Except I don't want it dotted. I want it solid again. Let's try this again. All right. So there would be my graph. So everything between 2 and 7 works. Everything between 2 and 7. So the answer to this compound inequality is the black part right there. Let me go ahead and highlight it. So this right here is the actual solution to that inequality. All right, one more and then we are done because I know you're ready to be done. All right, x is less than 2 or x is greater than 7. So I'm just going to actually repeat what I just did. X is greater than 2. I'm going to put an open circle on 2. Let me get my arrow back here if I could. All right, so that one's going to start at 2 again. That is all the places where x is greater than 2. And then I want to know where x is less than 7. All right, and that one's going to go that way. All right, okay. Okay, but now it says or. So now it could be either one or the other. Here we had to make both true. Well, here we only have to make one or the other true. So I want you to think about this. All right, red is true from 2 to the right. Blue is true from 7 to the left. If I said you could be in the red or the blue, where could you be on that number line? If you're in the red or the blue, you could be anywhere or everywhere, right? So this one is all real numbers, okay? Everything is either in the red or the blue, all right? Here on the top one, the black part's in the red and the blue, but here everything is either in the red or the blue, one or the other. So describe it in words. This would be all numbers between 2 and 7. All right. Oh, I just looked at this. It's different. It's not the same thing. Oh my goodness. Oh my goodness. Mr. Reeves, you need to read more carefully. You guys see what I did? I looked at these two and I thought they were the same. Scratch everything I just said. What I just said was true if that one said or. Let me try this again, shall we? Okay, sorry about that. X is less than 2. All right, so X is less than 2 is going to go the opposite direction. I bet some of you are going, Mr. Reeves, you did not read that correctly. You were telling me, but I couldn't hear you because you're not here to tell me. All right, that's why it's nice when you're actually in class. You can actually help me out so I don't do the whole problem before realizing that I did it wrong. All right, there we go. Or X is greater than 7. Okay, that's better, isn't it? X is less than 2 goes that way. X is greater than 7 goes that way. That idea of or is the same, all right? You can be in one or the other. So now we're going this direction and that direction. So now we can be anywhere except in that middle area, okay? So if I were to say, where could I be? Where are the solutions? Well, I could be over here or I could be over here. All right, by the way, even though I highlighted over it, the open circles would not be included. Okay, describe the solution set of the compound inequality. X is less than 2 and X is greater than 7. So this one right here, now they're taking that second one and putting the word and that one would be no solution. Okay, because if I said, where can you be both in the red and the blue? That would be nowhere. This one, describe the solution of the compound inequality. X is greater than 2 or X is less than 7. Well, that's that one I accidentally did before. That one was the all real numbers. Okay, so if you want to see this one right here that I already did, rewind the video and you can see that. Okay, I apologize for that mistake, ladies and gentlemen, but that is writing and solving two-step inequalities. Solving two-step inequalities, that's lesson 7.3, and writing two-step inequalities, that is lesson 7.2. All right, that's it for this video. Have a great rest of your day.